Hello, good morning, good afternoon. Welcome to the third day of our third Fortaleza Austral Spring School. I'm Tallita Tavares, and I'll be chairing session 5 that will be about blue growth. Our first speaker is Marc Garcia-Duran. He is the executive president and founder of the incredible Underwater Gardens International, a theme park that offers visitors a new experience of connectivity with the ocean through science, art, and education. Marc is an architect and urbanist and uses the geometry of nature as an inspiration to link science and community awareness to the destruction of our environment and species, as well as technology to address the regeneration of marine ecosystems. Thank you, Marc, for your participation. Please, you may start your presentation.
Thank you, Tallita. Good morning, good afternoon. Thank you for inviting me to this panel. And with no further ado, let me share the screen. Okay, so I was asked to talk about the vision that Underwater Gardens we have on regeneration and in blue growth. That means for us that how we connect economy, finance, and the regeneration of nature. Actually, when you talk to the guys in finance, they always ask you, where is the bacon? As in, where is the money? Where is the profit? And well, maybe that's not the image. Maybe that's an image that comes from the 20th century, but maybe not the image for the 21st century that we want. I mean, we live in a society that's fascinated with technology, and we have forgotten that the most fabulous technology is nature, and here's the proof. I mean, nature is this technology, if you want, that is and is able to foster life. It is, as you see, a terraforming technology. I mean, a technology that allows for life to happen in this rock floating in the universe. Actually, it's a technology that has created us, humans, and that provides the scenario for the journey that we have started, no? I mean, a journey, an extraordinary journey, as I say, a journey in which we have been tested in many ways, no doubt, and through which we have developed a relationship with nature, mostly with the purpose of mastering it. I mean, and we have done it pretty well. We've done a pretty good job. We are already 7.7 billion people, and it looks like people like Hans Rosling are teaching us that we are facing a growth towards an stabilization around 11 billion people. That means that there has never been so many people alive at the same time on planet Earth, and that objectively, this is the basis for a change of paradigm. This change of paradigm has to take care of how we've been using technology, how we've been doing things so far. I mean, our business models that define the way we use man-made technology is multiplied by this bloom. I mean, we're reaching this point of saturation. We're not allowing nature's capacity to digest and process our waste to perform properly. I mean, we're arriving to this point of saturation, and we need to understand that actually nature is what is giving us these conditions for an harmonious life. Within nature, we all know that all life comes from the seas, and actually this ocean is the one that provides the cycle of life. I mean, the cycle of water that supports all this life. It is the regenerative soup, and is what provides the planet and us with the substance and the support for life. And well, what's behind this image of this blue horizon is these sea forests. I mean, sea forests that are truly the workers that provide us with this substance for life. And It's a technology that is really beautiful, really beautiful. It is actually the universe expressing itself, expressing its craft and its geometry. But right now, I guess we can relate to this famous sentence by the astronauts. Houston, we have a problem. We need to really regenerate. We need to go into a new paradigm. This new paradigm is a great opportunity also, because with the connectivity we have and the amount of people that we are already feeling and understanding that our actions resonate, and resonate very fast. In a way, we have a resonant box for the subconscious, and we have a great responsibility. And the first responsibility is actually to go within ourselves, because if this element of resonance amplifies what's going on within, maybe we need to go back to understanding ourselves. This is somehow what the great meditators point out. Maybe it's the time to dive deep in our inner waters and find not the bacon, but the inner waters, the big fish. The big fish, as David Lynch says, no, in his transcendental meditation courses. The idea is that we come from a 20th century, which is the century of the ecosystems that have made their, actually have provided us with the technology and the knowledge that we have nowadays, that we inherit from this period. And we need to be very thankful from that. But we also need to understand that this production of ecosystems has reached its levels of saturation, and we need to change into a systemic thinking, an ecosystem, an eco thinking. 21st century, to me and to the company, is the century of wisdom, is the century in which, with all this technology, we need to address a significant change, and we need to change from being exploiters to being caretakers. The image that I want to convey is the idea that this rock floating in the universe has this ecosystem, this natural system providing life, and on top of it, we have created as human beings, we have created this ecosystem, this economical system, which is the product of our abstract minds, and it has been behaving somehow as it has exploited this natural system, and now we need to change into creating this new adherence between the two systems. We need to start changing into taking care, providing design from this economical system into a caretaking of the natural resources. This is what I call the gardener paradigm. I mean, the gardener paradigm means that we have to still receive from nature, but we also need to understand when we have reached this point in which we need to become truly aware of our role in the ecosystem. And to do so, to become these gardeners, to enter this gardener paradigm, this underwater gardeners paradigm, we need to understand that we need to start to think systemic and cooperative in order to increase intelligence per square inch in any human intervention. That is the transversality of knowledge. In our company, we have decided to approach all of this and to embed this culture in the company, and we have started developing 3 vectors of activity or work. The first one is, if we want to really adapt and to really become these caretakers, we need to understand how the system works. And that's what we call the sensor project. We need to sensorize, to observe what climate change is doing to our seas and to the sea animal forests, and collect the data in a significant amount of points in the planet in a significant amount of time, so that this data becomes relevant and a good basis for understanding and proposition. Actually, this understanding and proposition is what we do in the second area of our efforts, which is the live reef technologies approach. Here we have developed, we are taking profit of the fact that this is a unique moment of technological convergence. We have new systems of production, 3D printing, etc., and amazing tools for thinking with big levels of data. We have generated the Reef Hopper protocol. The Reef Hopper protocols allows for designing bionomic structures designed specifically for every location. And we designed this substrate for the growth of new sea animal forests that we call the smart enhanced reefs. And obviously this is very beautiful, but at the same time, it's a part of the economical system, so it needs to have a revenue. And we have developed this new business plan called the regenerative theme parks. In a way, we're crossing existing elements to create a new model for sustainable tourism. This sustainable tourism is actually is where the bacon is, and this bacon is metamorphosed through the project into ecosystem restoration, biodiversity enhancement, as you can see in the image, and which is the basis for actually blue carbon capture, but permanent carbon capture. It also is a great tool for biomass increase, and it allows us to somehow change coastal management to produce a more sensitive, ecologically sensitive approach. The product in itself is a new product. It's the product that allows for these financial guys to start to understand that there's big profit in taking care of nature, and it allows for the guys in the environment to understand that maybe the financial guys are not the enemy, but they could be partners into creating a sustainable, from all points of view, new model of harvesting the sea. Our product proposes an environmental sustainability and profitability, this link between these two worlds. It also makes something that I think is very relevant, which is you get independent scientific research, which is funded by tourism, and it becomes a place where scientists can really reach wider audiences, because it's a place where you can learn through play. It's it is in itself fostering education and culture, and in the end, it produces the most important fact for this change of paradigm, which is environmental awareness. The project was born out of this conceptual engine, what I call the virtuous circle of the 3 E's. The first E is edutainment, education and entertainment, put together so that people are willing to have new experiences and are willing to pay for it. And it is aligned with the new trends of the economy. As you know, we even the financial guys in the banking system is becoming more and more aware that we need a change. And this alignment with this economy and this very profitable model allows for financing, finally, sustainability, true sustainability, through the protection, management, and restoration of ecosystems, and very, very important, the data gathering, the scientific monitoring. I mean, this independent research laboratory. The park itself is, I always use this metaphor, that it is like inventing the ski resorts, with a big difference that instead of cutting down trees, what we will do is plant new trees. And furthermore, every skier, every diver becomes a caretaker, and every time they do an experience of sport, it is related to an action of enhancing this reef. And obviously, because not everyone is brave enough to go on the water, there's this garden gate facility where on land, most of the visitors can also understand, relate, and discover this wonderful world and this wonderful technology of the underwater sea forest. The sea gardens are these structures that we have developed technologically thanks to the fundings of the Spanish government and private investors. by which we have gamified the construction of the substrate in which this new ecosystem can thrive. And we have developed also the gardener's action. Here you can see the planting of corals over the structures. And obviously every diver puts its little grain of action into fighting or adapting climate change. Here's the little image that shows that human beings or human presence, instead of being the presence that destroys, erosionates nature, we become actively the builders of these new ecosystems in collaboration, obviously, with the sessile mobile natural organisms. The regeneration park facilities is the scientific background, as I was telling you, this scientific back office through which the dynamics are designed and followed. So it's not about creating a place that stays and we'll see what happens. It's a place where we have an interaction. And these interactions allow for the learning process to start. We're going to have to learn to adapt to this climate change that seems to be unstoppable. And well, at the core of these facilities, we have created these three elements: the research center, the academy, which is a museum science in which through emotions you can anchor your knowledge and your understanding on why it is very important that you behave in a certain way, not to be harmful to what actually gives you life. And we have also enhanced the experience of a vacationer, and someone who goes on the water through the dive center and through the facilities that all around these three core facilities give you the experience of the world that is already possible with the technologies and the cradle to cradle approach on materials and food and fair trade that are possible nowadays. I think that somehow this is briefly how we have interpreted in Underwater Gardens the question of the financial world. Where is the bacon? To us, it's not about bacon anymore. It's about understanding where are the flowers, where are the trees, and where is the real profit, which is to keep our planet healthy, to maintain this globalization and this growth of population. Obviously, transversality of knowledge to make this project possible is very important. We have a huge team full of big figures, people from all over the world that have answered to the call of putting our knowledge together and create a new opportunity. And obviously, all these institutions that back this effort and allowed us to respond actually to the very smart agenda of the ODEs. One of the projections of this, or the big picture of this project, is that as each and every one of our parks is a sensor for climate change, we want to establish as many as possible as we can generate this sensoring network and obviously this big data generation for adaptation. Well, I think that's all, and thank you for listening.
Wow. Thank you, Marc, for such an inspiring lecture. Next, I will present Professor Adriana Giangrande from the University of Salento. Adriana is a biologist with a PhD in environmental sciences, and she is chair of zoology at the Department of Science, Biological and Environmental Technology. She will talk about an integrated multi-trophic aquaculture experience in the Mediterranean Sea. So, Professor Adriana, please, you may start your presentation.
Thank you, Tallita. Thank you. I want to thank all the the people that organized this beautiful course. And now I share. Oh, no, I'm sorry. It's okay. Wait a minute. Oof, sorry. No, okay, it's okay. Yes, we will have a talk about our little experience in a Mediterranean inshore aquaculture, experimental culture that is toward the development of an aquaculture, a sustainable and environmentally friendly aquaculture. This is linked to what Marc told before, because during the forthcoming decades, aquaculture, we have to increase production because following the increasing of human population, how we can respond to the growing demand of human. I think that the best solution should be a decrease in abundance of human population. But the economy suggests us that we have to grow indefinitely. And another solution should be that we become all vegan or vegetarian. But however, proteins are always a need for human consumption. A very important thing is that why the aquaculture increased so much during this last time, because the producing of 1 kilo of fish, you know that the cost of production, one kilo of fish at the environmental level is 4 times less than the producing a kilo of beef. However, also in the aquaculture, we made a lot of aquaculture development, we made a lot of mistakes. At present, the current consumption is reported to be 2,000 tons per year. 200 tons per year. And this led to the overfishing for most of the fish stocks around the world. One positive thing is that at present, more than half of the production comes from aquaculture. The other comes from fishing, but aquaculture increased a lot. And it was thought in the past that this should solve all the problems of the overfishing. This was not true, because it is necessary to increase the aquaculture and make it a sustainable, environmental friendly activity. That at this moment, it is not in this way. Even if aquaculture is identified by EU's blue growth strategies as a sector which could boost economic growth across Europe, and European members are currently developing national aquaculture strategies, giving a lot of fund for the improvement and increasing aquaculture activity. Which are the main problems which are related to the aquaculture? One of the most important thing is that the aquaculture is a source of environmental impact, causing pollution. So there are several techniques that were developed to respond, to answer to this, to the solution of this problem. But the other problem is also linked to the food production. because today we are going toward the production of fish, food without the use of fish meals and fish oils, because these in the past caused fish stock depletion as well. We are very crazy, because to produce sea bream and sea bass, the fish that the people likes more, we used the stock of pelagic fish. This is very, very crazy. And this is not sustainable. However, at present, the research is toward to the use of other protein source for food production, such as, for example, flour from insect, and not only from the soya or other vegetals. Okay. This is a picture showing which are the countries that are more the best producers of aquaculture product. Here there is not only fish production, but also, for example, mussel production. And you can see that is highly developed in Greece and also in North Adriatic, especially in Croatia. And it is reported that aquaculture have to increase a lot in the future. But if we don't solve this problem, the two problems that I told you before, it is impossible that aquaculture increase without, yes, it can produce more fish, more products, more sea products, but with a very high impact on the life. However, I will speak about mariculture, that is a branch of the aquaculture. Because for aquaculture, you can aquaculture can be also freshwater aquaculture and land-based aquaculture. Mariculture is that was more developed during the last year, and is the future of the aquaculture. Mariculture is made in the sea and not in land-based. Moreover, I will speak about especially of fish production, mariculture fish production. Mariculture is made by means of very large cages that are anchored at the bottom, and in which fish can be also at high density, and you have to feed them. However, also aquaculture can be of different type. And today we are developing the so-called offshore mariculture. That see the cages in very, very far from the coast in open sea, and is an alternative for countries with few suitable inshore sites where there are some conflict for space utilization. Open ocean mariculture, however, in which farms are positioned in deeper and less sheltered waters, have a lot of problems caused by the water, the action, the wave action, the storms, and so environmental conditions are very harsh in this environment, far from the coast. So technology must be more pronounced with submerging cages or shellfish culture system that have to tend to minimizing and reducing wave effects and the interference with boating and shipping. So this produce highest cost for maintaining this system. And even if we have in this way a lot of space to operate. And moreover, we can have a multifunctional use. You can see, for example, the production of energy that can be coupled with the presence of mariculture. Another problem, another positive factor is that the nutrients in this way are not a problem because they are diluted more than close to the coast. The mariculture close to the coast is called inshore mariculture, and is that which was more adopted until now, and is within 1 kilometer far from the coast, and or from 1 to 7 kilometers, and with a line depth under the cages about 10, 15 meters, also 20 meters, but always very, very low depth. Inshore is that is more developed until now, but it is also linked to this activity can cause the concentration of nutrients because the wastes are exerted directly in the water, in this water sea, and it's impossible a treatment of these wastes from production is not possible. So, two problems: pollution and space to put your plant. One solution to the two main problems that I told you before, such as the pollution and the food production, can be solved if we didn't make monoculture, but if we proceed as polyculture. That means not rear only one species, but a complex of species that are linked to each other through energetic, through the web, the trophic web. Monoculture, in addition, monoculture is very dangerous because we rear only species that are carnivorous, and it is as we rear lions in the terrestrial habitat. We rear very, very species that are at the top of the food chain, and this is very energetic, not good at energetic point of view. The polyculture is called also IMTA. That means integrated multitrophic aquaculture. That means to produce in the same site the different species that can act. Some species can feed on the wastes of other species. IMTA is a very easy concept because it's a natural circle of the energetic circle of the nature, and can be applied to different different systems, land-based, from inshore or offshore mariculture. The fish are produced with co-cultured species, and these are produced at very low price because they feed on the wastes from the fishes, we saw the plants, the productor, the company can have also marginal benefits. This is called also circular economy, you know. However, if we don't demonstrate that this system are really economically friendly, it's impossible to apply this system, because the economy is the most important thing in the application of all the technology, biotechnology. So in the polyculture, in other words, the polyculture life cycle impact for unit of fish produced is lower and becoming economically advantageous if the products that are arise from this system can be utilized as a byproduct of the bioremediation. But this system, it seems that in Europe there are very few plant systems that utilize a kind of IMTA. And for the moment, this remains at a research level and not a productive level. We have here some example. These examples that I told you are relative to salmon and macroalgae production or mollusks. And mollusks remain the species that are more utilized, because in this system at present only species with an economic values are used. So mollusks are the first one. After we have macroalgae and so on. But if you try to use other organisms as bioregulators, you have to create a market for them. Otherwise, the system doesn't work. So we did a small project that is called Remedial Life. I am the coordinator of this project, and we are working with CNR of Taranto, the University of Bari, and a plant called Maricoltura Mar Grande that is located in Taranto, that is in South Italy, very close to Lecce. Which was the objective and scope of the project? Mitigating environmental impact from aquaculture. This is the main goal of the project. So developing an IMTA, Integrated Multitrophic Aquaculture System, innovative at European level. And this is important, a system that can be applied only in confined environment, in protected area, so is related to inshore mariculture. Because if you try to apply this kind of system in offshore, this cannot work, because of the difficulty of the environment, and after a storm you cannot find anything. After the first storm, okay, so this is planned. The system was planned for a very protected area. The second goal is producing a valuable biomass as byproduct. So exploiting the produced marine biomass, edible or not. So not only mussels, but also other organisms that can be very, very important. In accordance with the market interest, in line with the term of blue growth. So we should enter in the new IMTA system. We should enter with this new IMTA system into the market in relation to the diversification and development of a virtuous circle which would encourage sustainability mariculture in Europe. However, the system that we have planned is working in south latitudes, and so I think for Greece system and so on, Israel and Greece, all the South Mediterranean coast. What we did, we operated in a very small plant, mariculture, which have only 15 cages, and we used 6 of them as control treatments, and the other 6 as control. In the treatment area, you can see we put some long line that are structure in which you can put your collector for rearing of all the other invertebrates, sorry. Invertebrates are put in vertical collector and macroalgae in horizontal collector in the surface. So we have these kind of algae, polychaetes, sponges, mollusks, and macroalgae. So mollusks are normal, especially in the Gulf of Taranto. They are one of the main products of rearing in the aquaculture. But the other are new in the market, especially spongy, but also macroalgae, because it's reported that the Mediterranean is too oligotrophic for macroalgae production. And lastly, the annelid polychaetes that are a novelty in this field. And we tried, here we are some pictures about different time of rearing. You have a sponge, the people from sponges people that are Bari, the University of Bari is responsible of the sponge. Here we have the algae, the macroalgae. This is a Chaetomorpha linum, and the CNR of Taranto is responsible of algae production. And below you can see the collectors, vertical collectors, showing the mussels and the polychaetes. Here you can see the one of this collector at 1 year of age, and here at 1 year half of age. They are, this kind of polychaete are tuberculous polychaete that settle on the bare substrate that you put in the particular collector that you put in the sea. They form a tube and they remain inside for a long time, and they are filter feeders, obviously, like sponge. Preliminary results suggested us that the system is working very well, because we made an ex-ante monitoring on all the area. Then we are comparing 1 year after the positioning of the bioremediators, and in the 2 areas, in treatment area and in the control area. And you can see up you see the situation in the ex-ante. It means before the positioning of the bioremediators, and you see that the A zone, that is the treatment, was very, very different from B zone, that is the control, because we put the bioremediator, our long lines in the area that resulted the worst area in terms of pollution. The red area is an indication of the presence of species that are indicator of pollution. But you can see that after one year of treatment, the A zone became like the B zone, that without bioremediators. So this is referred just at 1 year after the treatment. But we have that data now also of the second year, and all remained in this way. This means that the bottom, and you know that the benthic environment is a memory, biological memory of the system. This is an indication that the situation was improved a lot, okay? And look at the hard bottom that stay under the cage after the treatment. This is like a garden that Marc showed you before. You find that we have found that biodiversity increased a lot because the situation, environmental situation, was improved. This is another example with some colonial Schidia. Here you are some worms naturally settled on the anchoring block from the cage. This is a structure that is used to connect the cages to the bottom. Okay. And this is another results from this. Another preliminary results is how many kilos of biomass we produced in this first year. After 1 year, in the collectors that were put around the cages. Look at. We produced the mussels, polychaetes, porifera, sponge, and algae, macroalgae. If you think that the long lines are not so many, if you put if you cover a wider surface, you can obtain also higher biomass. But this was very impressive in my opinion, because we produced a high quantity of biomass. This is some picture from the sponge here, some moment. We tried also, people tried also several different method to understand which was the best for all the organisms that we reared. And the sponge, we obtained good data about biomass as a byproduct, and you have to think that the sponge biomass is a biomass that could be very good from an economic point of view, because you can extract several bioactive natural compounds from the sponge. So it could be good from economic view. But now I will speak about polychaetes, because they are my creatures. And you can ask to yourself, why polychaetes? long time ago, we made a lot of experiment in the laboratory condition, and we obtained a good performance. We observed a good performance from to consider polychaetes as extractors organism, because look at the small aquarium, 50 or 25 liters. This was the water coming from an aquaculture, a land-based aquaculture system, very, very full of particulate organic matter and obviously bacteria. And after half an hour, just the presence of 4 or 5 polychaetes have cleaned the water in a good way. And look at the Sabella spallanzani, that is the worms more abundant on our collector, but also Branchioma sp. They have this comes from always from laboratory experiment. They have a very high clearance rate, highest than Mytilus, for example, but also high from sponges and from ascidians. Very, very high. They are very efficient, and they operate also at a very small size of particles. So they don't enter in competition with Mytilus. They can be cultivated together, because moreover, we observed that Mytilus preferentially settle on the surface, while polychaetes settle in the deeper. So they also can process the wastes coming from Mytilus, and creating a very good system for biofiltration of the water. Moreover, we also analyzed Sabella, the species, the worm, by a biochemical point of view, observing that it's very rich in protein. It's very rich in protein, and also in omega-3, the good fat. So it could be utilized for food production. I thought about floor, Sabella floor, like insect, but very, very useful for to be attractive the food, because the fish like very much Sabella and other worms. So the first cycle that goes from February 2019 to 2020, July 2020, we produce this amount of worms for about 10 quintals of weight. These are the collector because we analyzed the growing rate of Sabella, and you can see in this picture the collectors with the Mytilus in the first meters, and but in deeper you can observe all the tubes of these worms that naturally settled, because we put the collector empty, and then they were a bare substrate, and they became full of these organisms. But I can show you a small, a short movie. This is relative to the June. It means only 6 months after the positioning placement. You can see that there are a mix of worm and muscle in some collectors, and This was the lateral collector. Ooh. Sorry. And after, this is the other long line, and in which you can see the muscles, the collector of the muscles. You can see also some decisions. You see that the muscles were shorter because the collector for polycates are 10 meters length and long, and that for muscle cultivation are only 5 meters, 4-5 meters. Spongy because they were mixed. And here I think it is a 4 meter depth, but think that the collector arrived at 10 meters depth. Okay, I think it's enough. Look at that, there is the best, the more abundant species was Sabella spallanzani, but we had also some other sabellids that can be utilized also in aquariophily, for aquarium as ornamental invertebrate. Here there are some pictures from the first year, operation of the first year collecting. And here is the growth rate of Sabella. Look, you have a collector having 1 year and a collector having 1.5 year. You can see the length that is the length of the tubes that proceed like linear, but instead the weight in Sabella is very strange because at first they grow only in length, then they become fat, fat and fat. This led us to plan that the grow is better. That is better to collect them the next, not in December, but the next to keep them for another time. This is a collector from December, and so. Oh, what we can do with the biomass of the worm? We can use. I told you that the first goal is the environmental improvement, but the biomass is the byproduct, and you can use them as ornamental animals or fish baits or producing fodder. We also experimented an innovative fodder using Sabella, flour of Sabella, but also for extraction of active compound, but I cannot do, I think the time is over. I want to say you that it is not, that the system function, but we had a lot of difficulty in processing the collector after the collecting for the separation of biomass. We have to find some easy techniques to do this, because this is the main problems that remain to be solved to make this system environment economically friendly. So we are still investigating on the possible biomass exploitation, but also on the collection, which at present is prohibitively expensive. And for the moment, we can say that the mollusks remain the most profitable biomass. For general conclusion are that the system is particularly efficient. The polychaetes are extractor of organic matter that is trapped for the worm growth, but also in the tubes. We are proceeding with this kind of study. The collector that we used also works as a physical barrier, because after a year, each collector has trapped a large amount of particulate and hosts a significant macrobenthite biomass, consisting of both sessile and vaginal fauna, such as Schiedians, that are used also beautiful biofilters, but also mollusks such as Ostrea edulis and Lima yans, which are important especially for the possible economic return. I say you another time that we have to find a method to separate all these organisms from the collector. So another important thing is that the presence of this vertical structure increases biodiversity, modifying the spatial structure of the original substrate with positive repercussion. However, our proposal, if we consider the problem of increasing aquaculture for increasing demand for human consumption, this project, this proposal can be seen as a drop in the ocean. Because as I told you, for the moment, this system is only is still an experimental. We are only at the beginning of the possibility to apply at industrial level, and for this we have to demonstrate that we can use the biomass of the organisms that we produce to obtain environmental improvement. Thank you very much. And sorry, because I thought I was not in time. Okay. I am in time.
Thank you. Thank you, Adriana. This was a wonderful presentation. I have so many questions to do later at the discussion. And now our last speaker is Professor Sergio Rossi. He's a visiting professor in Labomar and is professor also of the University of Salento. Sergio is a biologist with a PhD in marine biology. He performs research on the ecology of marine environments and the development of methods and technologies for the sustainable use, conservation, and recuperation of marine degraded areas. So please, Sergio, the floor is yours.
Thank you very much, Tallita. Okay, I will try now again to share the screen. I think that's all. Perfect. Well, I think now that's perfect. We can just start. And let me just put this here. Okay, I want to just make a snapshot about another kind of approach on this blue growth, which has been not very explored yet, and is deep sea restoration. Within deep sea restoration, I want to just show you some concepts and some things that can be interesting. In a program that we are just elaborating now, and we're just starting to just set up of the pieces of the puzzle to try to understand if we really can, how can I say, help in the carbon mitigation which is really a huge problem that we have, and we have to solve in some way. Of course, the first way has to be change your way of thinking. That's, I think, it's quite clear. And even if we have this stretching society in which someone is not believing, the other is believing, the other is misinformed, the other don't know how to do, the other is depressed, and so on and so on. As a scientist, we have to just try to give solutions, as I will tell. So just start for what about nature can give us to mitigation. The first thing is have clear the concept of ecosystem engineer organisms. Ecosystem engineer organisms are all those organisms which make three-dimensional alive structures, like, for example, the trees, and that may shelter other species that take benefit of this. Let us describe them as houses, okay? So they take advantage of many things. They take advantage of their profitability as food administrators, shelter, also because it's extremely useful for species interaction. They have key roles in biogeochemical cycles, and they are also this kind of organisms. They are also carbon sinks. They are also carbon immobilizators, which means that in some way they are also an ally. Among the ecosystem engineers that we are more used to think, we are more used to know, are those which are on land, which are the trees. Trees which compose this forest, which can be tropical forest, boreal forest, Mediterranean forest, and so on, or shrubs or other kind of terrestrial vegetation. But underwater, in this 70% of the surface of the sea, we have other kind of forests. We have marine forest in general. These marine forests are very diversified. We have vegetal forests, like, for example, the kelp forest, or we have tropical coral reef forest, in which the dominance is not vegetal, but it's animal. It's this called animal forest, because they are composed basically by animals which are suspension-feeding organisms. In fact, if we have to make a precise description, a more precise description of what an animal forest is, just digging in this kind of forest of three-dimensional alive structures in this ecosystem engineer based habitats, we will see that the animal forest is a living three-dimensional structure similar to a vegetated forest, but composed basically by sponges, cnidarians, bryozoa, ascidians, and other sessile animal organisms in the ocean benthos. And if you think about it, one of the most interesting things is that 90% of the space in which there is life is on the oceans. Because this is three-dimensional, you have this three-dimensionality, okay? You have not only the surface, like on land, is 10%, in which we have trees, and we have within this forest several kind of animals and other vegetables, of course, and other organisms. But you have this three-dimensional ocean water column in which there are many organisms. And in the sea floor, if you also think about it, most of the organisms live below 50 meters depth. So these marine animal forests, which are dominant below a certain depth, are very important structuring the systems. You have mesophotic systems, sponge grounds, you have deep cold water corals, you have bryozoans, you have many organisms which are much more comfortable between the 50 and 1,500 meters depth, more or less, and even more, because there is no light, or a poor quantity of light, that makes impossible the life for the vegetated forests, which are composed basically by seagrasses and, of course, by seaweeds. So here we are. We have these three-dimensional alive structures sparse all over the world. Okay, that make a set of habitats which composed by ecosystem engineered species, shelter a lot of species, and also provide facilities and commodities to the organism and also to the human beings. The animal forest or the marine animal forest immobilize carbon, okay? Just I want to show you some numbers. Here you see what 3 Mediterranean gorgonias are immobilizing after a study made by Martina Coppari and our group, which demonstrated that 3 Mediterranean gorgonians may immobilize 0.014 tons of carbon per hectare per year, which is a rather humble number if you compare, for example, with the Amazonian forest, which is just immobilizing or sequestering 1.02 tons of carbon per hectare per year. Or if you compare, for example, with the wetlands, which has 0.19 tons of carbon, okay, per hectare per year. Seagrasses are the champions. These seagrasses are, the different studies just make a mean of 6.7 tons of carbon per hectare per year. And also in the coastal areas, mangrove areas are also retaining a lot of carbon. I'm centering the carbon because this carbon if we see it carefully, this carbon that is so-called in coastal areas blue carbon, this blue carbon is just part of the carbon that is from a common origin, from natural origin, okay? Maybe, for example, for respiration of the organism or for other chemical and metabolic issues, but also comes, of course, from the CO2 that we are introducing in the atmosphere by our industrial, agricultural, urban, and in general, human activities. So these organisms, in this case you see here, are immobilizers of carbon. And because they are immobilizers of carbon, they could be very interesting to preserve and to make something more than just contemplate them as a natural wonder thing. We have to keep in mind that they are true allies. In the case of the suspension feeding organisms, this marine animal forest, they have two mechanisms. In shallow waters, they may be photosynthesizing the microalgae that have inside, photosynthesize, and in some way help to the structure to immobilize carbon, okay? On the other side, most of the suspension feeding organisms are suspension feeders. So they really take advantage of the particles that are around them to capture the particles and eat the particles, digest the particles, and assimilate. So they are very, very good in trapping these particles, being, for example, active suspension feeding organisms or passive suspension feeding organisms. So in shallow waters, okay, we do have this mixotrophy, which is just the mixture of this autotrophic behavior and this heterotrophic behavior. But below this 50 meters, 60 meters, 70 meters depth, we will have fully heterotrophic organisms that only rely on the capture of particles. Okay, so let us just put this more clear, just to understand this point, because this point is essential to understand all the other points of my presentation. You have an algal bloom, okay, and this algal bloom in the surface waters from, for example, 0 to 150 meters depth, make a biomass, just grow, just develop a bloom. And this bloom is partly eaten, of course, by the zooplankton and enters in the so-called microbial loop. But an important part, depending on the area, goes to the benthos and is eaten by the suspension feeding organism. Okay, this is suspension feeders, passive or active, take these particles, and part of this biomass that is captured is transformed by growth in skeletons, in structures, which allow them to just occupy more space, be more efficient to capture particles, and so on, so on. Part of this benthic growth is immobilized. Could be immobilized for even few years or even few weeks. Some of the benthic suspension feeding, like some hydrozoans, are ephemeral, and they only live for 1 year, for example, and then this kind of retention is ephemeral. But others may stand for decades, hundreds of years, or even millennia. And a very, very small part of this carbon is permanently sequestered. When I say permanently, of course, please take into account that this is just, we are talking about millions of years, but is a smaller part of this carbon. So this is the sequence that you have to take into account to understand what are we talking about. So there is a lot of blue carbon in the ocean's bottom, but we just don't know how much, how it's distributed, and we don't know the real rule. This is really a drama. But even if this set of habitats of the marine animal forest are probably the most abundant habitats all over the world, we just practically don't know nothing about their present distribution and dynamics. So now we are realizing that in general, also in the land forest, we are losing an ally. What means this? This means that all these organisms, among many other ecosystem services, among many other facilities, among many other commodities, they are extremely efficient carbon sequestrators. They are extremely efficient in what we understand, what is the immobilization of the carbon for, I repeat, decades, hundreds of years, millennia, or even hundreds of thousands of years, depending on the organism and depending on the system. And so this beautiful place, this fantastic place, is a place that we are just step by step eroding at an alarming rate. In fact, most of the forests that we see now are just completely transformed forests. This is a red coral from it's a suspension feeding organism. It's a cnidarian, it's an anthozoan that is common in the Mediterranean Sea. And it is a red coral that has been harvested by the 1970s in the Catalan coast. In the same Catalan coast, okay, nowadays we do have these small corals. And this is very small. This is the quantity of carbon retained by the left one respect to the right one, by the big one respect the small one, is incredibly different. And most of these structures have been disappearing during the last decades or centuries due to the human action. In fact, one of the most problematic things of the marine animal forest is climate change. It's climate change. Climate change is devastating, for example, coral reefs, shallow coral reefs. You know, the news that they are coming from the Caribbean, mostly for Australian great coral reef barrier, and so on and so on. But if you think about it, not only climate change is now damaging and deeply transforming this kind of marine animal forest all over the world, but also things like, for example, bottom trawling. Bottom trawling probably is the most impacting action that humans are doing to the marine animal forest everywhere. Of course, there are other things like warming, ocean acidification, sea level rise, which are problematic and we will face as a problem. But at the moment, the real problem, especially in the continental plateau, but also in deep sea animal forest, is bottom trawling, which still is not banned. So now we have the opportunity to just think about it. United Nations make this decade of the oceans as a primary target. Preserve the oceans, but also try to understand how the oceans can help us to have an opportunity, as I see in the texts. In the text that I'm reading now, I see something like a claim that we need an opportunity to just readdress the situation, which will be not easy at all. Also, the European community and also United States is trying to do that, but the European community is already doing that, is very interested in this kind of new vision, not only on the oceans, but only in the natural system. Natural systems in which we try to, how can I say, we try to embrace the natural basis solutions, in which we try to make things very different from now. We try to take advantage of what we have, take advantage of what we need from nature, imitating in some case nature and restoring nature. So it's not a new thing. We made many things. We have done a lot of work during these last decades, but it's not enough. For example, we have made very, very ambitious programs of conservation management and also trying to protect marine areas in the better possible way. We have made these things, and some things have been working, others not. Some are very efficient, others are not efficient at all. But in some way, it's not that we didn't have made anything. We did it, but we failed because probably the changes that are just present in nowadays during the last 20, 30 years, no, it's not exactly nowadays, are so huge that it's not enough to protect, it's not enough to make a conservation plan. Conservation plan that sometimes is even seen as a problem for the society, because as Marc told in the last presentation, it's not only a matter of preservation, conservation, it's a matter of awareness, it's a matter of implication, it's a matter of complicity with the nature. It's not only just to conserve and protect, it's just make a different plan, make different things that may help us. Why you should preserve these complex ecosystems? I mean, in fact, I just told you that they are ecosystem service providers and so on and so on. The thing is that we are simplifying our ecosystems. Pauli in 1999, Daniel Pauli published a very interesting paper about fisheries in which he pointed out that many of the big organisms or long-lived organisms are disappearing. And this was 20 years ago. And he claimed that we are going in a really wrong way about that. So we do need absolutely to address a way to face nature, not only as a point of harvesting, a point of exploitation, but a point in which we run with harmony, with ecosystem-based solutions, as Professor Rafael Sardà told yesterday. In fact, Jackson, in 2001, in the proceeding of National Academy of Science, published a very nice paper in which very simplifying the things, but at the same time giving a deep thought about it. He said that after exterminating from the ecological point of view the large bovine animals like sharks, like turtles, like manatees, like whales, and so on, we are just now destroying those organisms which are providing these habitat structures. And this is much more problematic than we think, because microbes in some way, or not very complex and short-living organisms, short-living metazoans, for example, or short-living algae, and so on, are taking advantage, because energy, as you know, is not disappearing. Some organisms substitute the organisms that have been just swept out from the system. So both these three-dimensional life structures we have in the bottom and all these organisms that are in the pelagic habitats are disappearing from the ecological point of view and have no more energy and matter rule anymore. And this rule is substituted by this microbes, let us say, in a very general way. So now it comes to think. We do need real commitment. Scientists have to have really commitment with this kind of problem. In some way, we have been in an ivory tower. Giovanni Bearzi, in a very, very nice paper, which is called Marine Biology on a Violated Planet, From Science to Conscience, is extremely provocative. And the first thing that he says is something like, move beyond marine conservation on paper and avoid self-serving complacence. Because we are self-service complacent. Most of the scientists are self-service complacent, and they are not committed with the real problem. We do have to break this barrier, even if this barrier may be in some way dangerous and in some way may give us, may just put us in a problematic, let us say, environment. The first thing is this. The second thing, among other things that is this very nice paper say, is that we have to endorse a more ecocentric and holistic world vision, which has already been said by Marc just a few minutes ago. In fact, this is essential. We have to understand that we are part of the nature, and we don't. We just don't. And even the persons who are not committed with the problem, they don't understand sometimes, me too. I mean, this is the, I just put myself in the first plane, in the first row of all this. We have to understand that we are nature, and then violating systematically the nature is not the way to survive. So saying that, what can we do? Is the moment to take action? Yes, of course. It was the moment just 30 years ago when the first IPCC report in 1989 was public. We know that was the point. But how we do that? How we can take action? There are many, many, many ways to take action. I will give you one example, which is a little bit provocative, okay? And you have to understand that this is just a serial of thoughts that can be shared and can be discussed later on also in the questions that you will have. So here's the point. The point is that, for example, when we see this bleaching effect with this dying coral reefs in Australia, for example, people in Australia, like, for example, Magdalene Van Oppen, just discuss the possibility to intervene, to make an active intervention in the nature. They call basically the assisted evolution. What they say is that trying to take those corals and those microalgae that are more resistant to bleaching, they could save the system, or if we have to be honest, they could save part of the system. They know that, of course, the actual coral reef system will probably disappear if we continue to do what we are doing. Probably in the next 30, 40 years, it will be very difficult to see a coral reef, a tropical coral reef, as we are seeing nowadays, because there is an accelerated degradation. So they decide to make this very, very, very brave and very, very polemic program in which the Australian government was committed to save the Great Barrier System, making a direct intervention, in this case with the assisted evolution, in which the main thing is try to select those generations, those genetic elements also within the population which are much more resistant. And they did it. They did it, for example, cultivating for more than 200 days, if I'm not wrong, microalgae, which was resistant up to, it was resistant to thermic shock up to 32 degrees centigrades. Again, this is intervention. This is just not only conservation, even it's not only management or protect something, it's just start to intervene, to make intervention, to make a program within the natural habitats. Going a step forward, I don't know if you have been hearing about the last 10, 15 years. It was very common. I just, even if I teach a class about that, about some of these very, sometimes strambotic, sometimes very, very strange solutions that gave the possibility to make geoengineering to mitigate climate change. These are geoengineering proposals in which you try, for example, to increase the reflectivity, making artificial clouds. You try, for example, to increase reflectivity of the sun coming, making aerosols and making small disks that try to impede the arrival of the sunlight. You have also more natural carbon mitigation approaches like afforestation, which is applying, trying to make many other approaches in this way to try to mitigate climate change. In fact, we have to think that basically there are this kind of approaches when we are talking about geoengineering, which will be more planet geoengineering. On the one side is the greenhouse effect, those that are impacted the greenhouse effect, and the other is intended to mitigate the incoming solar energy. In incoming solar energy is all mechanical basically and chemical, which is basically decrease the incident solar radiation and increase the Earth albedo. Albedo, I remember to you, that is this, for example, the ice in the Arctic and the ice in Antarctica has a high albedo because it's reflecting, because it's white, is reflecting the sunlight. Surface, black surface absorb more sunlight and more heat. White surface absorb much, much, much less heat. Okay, this is the albedo. And you have this surface albedo, cloud seeding, stratospheric aerosols, engineered particles. The other is the greenhouse effect, reduce CO2 emissions, and try in some way to, for example, switch energy sources, improve efficiency, and this kind of CO2 capture storage with fossil carbons. At the end, here you have remove CO2 from the air directly. And you have two possibilities. One is the chemical schemes, which are solvent regeneration loops and altering earth alkalinity, which are, from my view, as the others, for example, putting all these disks in the stratosphere and so on, are a little bit dangerous from my point of view. Very dangerous, in fact, because I don't know. The other is the biological schemes. It's try to rely on nature, okay? And within these are three, which is just reforestation, also augment the biomass, and also iron fertilization. We will talk about it just in few seconds, okay? In few minutes. So just think about it. One of the solutions is nature. So is take advantage of what we have in nature, okay? Can we give any opportunity to the oceans to help us mitigating this greenhouse effect? Theoretically, the ocean has all to do that. Remember that 90% of the heat that is incoming from the sun is in the oceans, is coming and is just stored in the oceans. The oceans are taking a very important part of the CO2, for example, and this CO2 enters in the oceans and then in some way also makes more acidic oceans, lowering the pH. So what we can do is just try to see if the oceans, using these kind of three-dimensional alive structures, may be a good way to help, I repeat, help to mitigate this kind of CO2 excess. Why we don't immobilize the carbon in these three-dimensional alive structures? Why we don't try to part of the carbon, that is the CO2 that is going to the water, and part of it is transformed by the photosynthesis in the microalgae, and part of it is just eaten directly because it's of the microphytoplankton, or because you eat the zooplankton or the detritus. Why we don't try to do that? I repeat again this kind of scheme to have clear what we are doing. The first thing is immobilize carbon here, just trying to stimulate the algal bloom, stimulate the algal productivity. So because benthic organisms are eating directly or indirectly in the organisms and the particles that are in the water column, we try to do this kind of approach. Just in some way, this is based on what said John Martin. That was much provocative, which was, give me a half tanker of iron and I will give you an ice age. Because what we demonstrated, and many other, like for example, Victor Snezacek and other people that was working with that were focusing in, what they said is that, and they demonstrated during the last 40 years, is that iron is a limiting factor for the growth of microalgae. Microalgae need many things. It needs CO2 for the photosynthesis, nitrates, phosphates, but there are some microelements which are essential for the possibility to growth of this microphytoplankton. So what he says, if you give me enough iron, I will fertilize the sea. The algae, the microalgae will take the CO2, and the CO2 will go from 380 ppm to 100 ppm. Of course, he was exaggerating, he knew it, and all this thing was just a sentence to just be provocative. But in the 2000, some people that has been working with this kind of iron fertilization models, they were making a climate change mitigation project, which is called low-effects experiment. This low-effects experiment, as you see here, you have a ship which is fertilizing, okay, the water column. The water column just grows up the phytoplankton, which is consumed by the zooplankton, okay, and you control everything in the sense that you control the environmental or biological parameters of the water column. And once you have this phytoplankton eaten by the zooplankton, part of this phytoplankton and feces of the zooplankton and the detritus are going to the bottom and are immobilized for decades or centuries, okay? This is part of the normal cycle, but it's just in some kind is pushed a little bit up in the sense that you are fertilizing in a higher rate, you are fertilizing the area, and then part of this carbon is just immobilized for a certain period of time. Okay, this is the scheme, the general scheme to make this carbon mitigation project. So the results were very interesting. The results you can find in several papers. And if you see, if you look at this graph, you see that, of course, there was much chlorophyll. Chlorophyll is this molecule that is essential for photosynthesis and describes the biomass of the microphytoplankton, for example. This chlorophyll was much more abundant. If you see, these are times of days of fertilization time, okay? You have this kind of fertilization through the time, out of the patch, which is the down graph, you have nothing. Practically in the open ocean, there is a very, very low concentration of chlorophyll. In the upper part of the ocean, at 100 meters, 150 meters, we still have this high concentration of chlorophyll that was developed because it was developed a bloom. Of course, this has many problems, I have to say, but now imagine that to take advantage of this bloom, of this algal bloom, and instead of waiting that this algal bloom goes to 3,000 meters depth, as it was previewed in this low-effects experiment, and they demonstrated that this was in this way, part of the biomass arrived to the bottom, you make it a little bit or much more shallower, okay, and you try to do it immobilization carbon in or benthic suspension feeding organism, okay? You take the continental shelf area in which you have 80 or 150 meters depth, and then you try to make the same thing, but take into account the populations that must be there. If you want, we want to be more efficient. If you want to really optimize, we have to make an intervention. This is why I talk about the assisted evolution. Because in this case, what we can do is first make possible, okay, the restoration program with symbiotic enhancer reefs in which you study the possibility to actively transplant benthic suspension feeders and put them in the bottom in artificial reefs in the continental shelf that, as you know, is mostly soft bottoms. Okay, you put this kind of enhanced reefs down in these areas. Okay, then you study very well and adapt to the organism needs, to the organism mostly advantages, optimized possibilities to make this kind of carbon particle capture. Okay, making this kind of artificial reefs, of symbiotic enhancer reefs, sorry. And then you apply what we know, large generation restoration methods, because we do have all the elements to do that. We know how to cultivate the corals, how to cultivate sponges, how to cultivate many organisms that we can transport down. And you cannot say that we don't have the methods. We do have the methods. Because now, for example, with deep sea mining, we do have the ROVs, the remote operated vehicles, and other kind of material that can be used efficiently to do that. So don't say we don't have. The problem could be another, is that probably it's not so profitable. Respect, for example, extract minerals from the deep sea, like cobalt, zinc, or other minerals. So we do have the methods, we do have the technology, we have it. It's only a matter of real voluntary. We do need to think that we can do it. And we have also other things, because now we know that it's not just, for example, Lorenzo Bramanti yesterday in his talk tell us a very interesting talk. He told us that it's not just a matter of transplantation. We know now how the patch works, the organization of the population of benthic suspension feeders. We know how much current is the best. We know what the orientation has to be. We know many things now to enhance, to optimize through the optimal foraging theory what is the best for these organisms. Also the mixture of different species and the change of the hydrodynamic conditions to enhance the carbon immobilization. So we do have, and we can do that, taking also into account that we know that some of these organisms grow very fast and immobilize carbon very fast. So we can do that. And we can select those species which can help us in a medium long term to have a response. Of course, making very rough calculations, very rough calculations that have to be taken with caution. We know that without a very optimized sea forest, restored sea forest, we can immobilize, okay, as much as 0.52 tons of carbon per hectare per year. Now take into account these numbers, which I repeat, please, are very rough. The total surface of the seabed is approximately 354 million kilometers squares. From this surface, 6% is continental shelf, 21.22 million kilometers squares, okay? Just imagine that we do have, okay, in this restoration plan, only one of 10,000 parts of this continental shelf are viable for this kind of application, of this kind of restoration. We will have 212,000 hectares to be restored, to be target of our plan. And this means that we could have from 100,000 to 424,000 tons of carbon hectare per year immobilized, which is not a very high number if you think about it. But we will later on say that this is really a very good number because it's very conservative on the one side, and on the other side could be a starting point to regenerate a part of the oceans that we need. We also have other areas like submarine mountains in which we have similar possibilities, and we have thousands of submarine mountains in which we can just think about the possibility to make a good restoration plan. And remember that these alive three-dimensional structures are perfect also for enhance of the biodiversity, the biomass of fisheries, and so on, are not only carbon immobilizers. So it could be a really win-win situation. Of course, there are many problems associated that we think about. The first is the effect of the blooms and the control of the hypoxia. If we don't control the bloom of the algae, we may have problems there. We have to take into account this, but this is also a part that can be just studied and can be modulated. Of course, also the sub-bottom transformation and the benefits of the benthic hydrodynamics is transformed. So we have to take into account also this kind of potential impacts. It's very important that when we make these plans, we carefully use science to do that. And on the other hand, also we have to be very careful with the alien species connectivity, so that the organisms which are already in some way spreading all around the benthos are not anymore capable to spreading this. But we are gardening, so if we are gardening, we can just try to control those organisms which are not interesting, like we are doing in our gardens every day. And we also have to consider the effect of climate change on this marine animal forest, the oxygenation, warming, acidification, but we do have enough knowledge to put the things in a way that it may last for many, many, many centuries. So we have to take a decision. We are part of nature, so what we do, we just go on as we are doing, we just make nothing with nature, or we try to have a new future in which we, of course, are making an intervention in nature, which is not good. I mean, I don't like it, but in some way you have to do it if we want to just readdress the situation, take the right way. As Moreno Mateos and collaborators said, we have to focus that restoration science on the long-term centuries to millennia assembly of the greater ecosystem complexity, interaction network, and evolutionary potential approaches. So we have to think into the future, not only into the present. We have to think in the next generations, and we have to think in the long term. So these kind of solutions may be interesting, even if looking at these numbers, we get very depressed. We see this kind of numbers, and we get very depressed, and we see, well, but your numbers were extremely low. Take into account that we are emitting so much carbon. Of course, we do have low numbers. The thing is that we have to first change completely our model, or societal and economical model, and then concurrently make restoration plans. Restoration plans will be completely useless if we don't change completely our minds. Thank you.
Oh, thank you, Sergio, for such a excellent presentation. Indeed, we have today 3 wonderful presentations, right? So thank you, Marc, Adriana, and Sergio for this. I want to thank you also for showing so many possibilities that we have in this moment that we are facing. Né? I think that we are indeed in a war. Yes, and the other guys, if I can call them this way, they are playing it hard. I think that almost they are playing like scorched earth or tierra quemada tactics, because they are destroying in a rapid path. So there are moments like this that show people that indeed we have possibilities to fight back. But as Sergio said, we have to take action. I think that as we have a great power, that is the knowledge.
Yeah.
And with power can come great responsibility. Yes.
That is true.
And our power is knowledge, so we have to spread the word, share this knowledge to people. So we are going now to the discussion. Okay. I have here some points and other from the chat. Okay. And just continue. And I think we have an opportunity to make things right. And all of you showed how we can do this. Yeah. So this is a great opportunity. Also, I think that Marc showed an excellent point on how maybe we can convince the money guys, the financial guys, on how conservation and business in a sustainable way can also be profitable. Yeah, as also showed Adriana. Yeah. So to the questions. First, Marc, those artificial reefs that you showed, they are planned or they are already installed?
What?
Those reefs,
or
those reefs that you showed in your presentation, they are functioning, they are already installed?
I mean, some of them are,
Okay.
and part of the presentation was mostly based on what we are working on right now, is the creation of a wider and more rotund, more important intervention.
Okay.
The prototyping and the process of testing has been done, and there's an additional part of it that's being done right now, actually. And we're negotiating right now the permissions to install the big one.
Okay. And you displayed the software. You talked about the software designed to plan these reefs. So it is dangerous to the system, to the environment, if you use wrong artificial reefs.
Okay, this is a very good question, but the answer is that trial and error has been on artificial reef production has been done since we started to have boats and we started to have accidents in the sea or wars, and we started to sink those boats. And we have progress on the experimentation of sinking things and stuff on the sea for many centuries. And actually in the last 30 years, 40 years, there's been an increase of a lot of artificial reefs that have been used for many, many purposes, usually on 1, 2, or at least 3 purposes at the same time. But the quality of design of these reefs has been very low because they usually are a system of production of something else, or they don't have a profit in themselves. They're a cost. So what we've done is we designed this approach of having reefs that are not a cost anymore, but have a return on investment. That is so through the business plan that we developed around them. On the other side, the design is based, the idea of increasing this intelligence per cubic centimeter of artificial reef has made us understand that we can cross a lot of data, and obviously we do an interpretation of this data, to create these designs, but we see these designs with an open question. Actually, the open question is this going to fit exactly this ecosystem, this local ecosystem we're designing this for? And so there's this gardening idea that we're going to be following and monitoring the results and adjusting the following versions of the briefs. So it's a learning curve that we're starting, and this learning curve should bring us into a situation in some years to be very accurate and very specific with our designs.
Okay. Thank you, Marc. The other question is to Marina. No, desculpa. Sorry. Adriana. This question is from Jadson Lima. He asked about what are the difficulties of implementing IMTA?
The difficulty in implement?
The IMTA.
Yeah, to implement, which are the difficulties? And the difficulty are that we are, I told this, all the presentation, you have to, we have to produce organisms that can be of valuable biomass to be the system, to make the system functioning, working. And for the moment, the only organisms that are used are mussels and macroalgae, laminaria in North Europe, together with salmon.
Mm-hmm.
The organisms that we proposed are new, and there is no market for their biomass. This is the problem. And you have to produce a biomass whose costs are not high, prohibitive, to be exploited. This is the only... And this is especially for the mind of the companies that have to apply this kind of system. Is an economical, is the economy that dictated the law for the development. And we have to work to make their production more easy, more as possible, and more economically friendly for the company. This is difficult. Okay.
This is difficult, but it's also a strength, differential, because the aquaculture can be indeed an excellent alternative to the usual type of fisheries that we have. But if the aquaculture is made in an intensive way, but exploring the environment in a wrong way, or exploring producers or local communities, it also is not so good. Yeah. So I think that is this concern you have, that you said is a difficulty, is also a strength to the model you proposed.
Mm-hmm. Yeah. However, another problem is that at present the mariculture is moving towards open sea. Open sea that is very expensive and dangerous, because we have no space close to the coastline. But and also because aquaculture is interfere with the environment and producing pollution and so on. But if you use this system, you can use more more sites close to the coast. This is the point. The point, I think. I don't know.
Yes. And another question to Adriana is if you have experienced some unusual growth that made difficult to your culture. For example, you told about mollusks that you didn't expect to grow in such a great quantity. But this growth was negative for the cultive.
No, the growth is not negative. No. The site where we are working is not good for muscle growth, but close to the cages, it becomes suitable. It becomes good, the environment, and the muscle grow better. And then you have to think that all these organisms take away all the surplus and the surplus of energy that is produced by fish rearing. And all the but after you have to take away this biomass. Otherwise, if you maintain in the sea, all the biomass you maintain in the wastage, you have to take away. And if you take away the mussels, it's a good. If you obtain a good biomass, high biomass of mussels, it is good because mussels are consumed for human consumption. Okay, yeah. For the other, it's more difficult to have a market. This is the main reason because we are searching for a possible use of their biomass. Okay.
Okay, thank you. There is a question for Marc from Matteo Putigano. Can the establishment of hard bottoms on a soft bottom community cause problems like messing with the hydrodynamic dynamics? And most of all, is it ethical?
Okay, very fair question. One of the usual approach with the production of artificial structures on the water is sort of a reflection of how we humans have acted usually in the production of our built environment. Is that we usually just impose our needs on the environment, and then we expect the environment to adapt to them. Our approach is the opposite. The first thing we do is we analyze thoroughly and systematically the system in which we're gonna, or we are asking the question if it's possible to create this substrate, this new substrate, and if it makes sense. The first thing we identify is if there's something missing in the system that we wanna intervene into, so that it makes sense to create these new structures. That may answer a little bit on the ethical question. Ethics has many definitions. The one that I really like is that this is a Spanish philosopher that talks about studying human intelligence. And one of the basic struggles that we have in life is the decision between where do we put the equilibrium between what's good for us as individuals and what's good for the community. And this point of equilibrium is the distillation of many, many centuries of conflict, of human conflict. And so ethics is that point of depuration. No? So ethical will be understanding that human beings are not made for not doing any intervention. We're demonstrating that we can stop ourselves. We investigate, we go further, we touch, we use. But the conditions of the new paradigm, I think, make it very ethical to intervene, but only in terms of understanding how you're intervening and how you're taking care of the system through the intervention. So actually the design protocol and the software that we've developed has to do with that. And the approach is about understanding the ecosystem and understanding the physical system, the currents, the sea, the substrate, and understanding if by adding these new structures, we are improving the system itself and giving it a new chance, and a new chance to generate these ecosystems that should in the end become our sources of inspiration, technology, and understanding, so that we can help this change of paradigm and we can do what Sergio was talking about. No, right now, like, we need to change the model, and restoration actually more than something that's completely significant and is like, gardens in the Renaissance were these laboratories where they will learn about how to make plants more resilient or how to create new species, etc. And well, where our proposition is that we create these new gardens, these new scientific laboratories in which to learn how to be more ethical. Because actually we come from a century of being, we've been acting a little bit like teenagers, and we need to mature a little bit as a community, as a human community on the planet, and that is the new ethical that we need to invent. So to me, it's not possible to go back. It's not possible to reduce population. It's not, as this is a direct answer to Adriana's first comment. I think that as specialists on human population have told us, it's not possible to decrease. It's only possible to increase. And as much as we el reparto de la riqueza, if we share richness in a better way, once a society gets a better increment of the repartition of the goods, the population sort of controls itself. There's more culture, there's more planning, and so the pyramid stabilizes itself. So this stabilization is a natural phenomena once you've become more ethical. So what we are proposing as a model is an instrument for this new ethics. I hope I'm answering the question.
But Marc, you say that it's impossible decrease of human population, but for ethical
experience. Even the Chinese wanted to control their population by just having one kid, and statistics have shown that it was a mistake.
But you will have a generation with some problems, but after we can say better.
Sorry?
Because if we have, we apply some law to control the birth rate, you will have a generation in which you will have a lot of problems because of the aging of the population.
Well, problems are activate imagination and activate innovation. Humans only react in front of big challenges. And so we can see this as a blessing in disguise, and we can see all these problems we're facing are actually what we needed to wake up into a new step forward evolution.
But not increasing, to remain at this level, not increasing, because carrying capacity of the Earth is...
Adriana, the natural growth of humanity will lead us into a planet of 11 billion people, and we need to start refining our technologies and refining our business models so that we can sustain a world of such population. It's incredible how in the 14th century we already have people writing in the 14th century. They were saying that the Earth was already overpopulated.
I think that we have to take into account one when you see the people that is working on demography, they talk about this 10,000 or 11,000 this billion people, these 11 billion people in the Earth, because of course what it says that in a certain point redistributing things, what will happen is that at the end we will have a steady state in which you will have a couple, whatever it is, and two persons, two people or one people. Probably due to this will maintain basically an overgrowing population. In this very moment, this is not feasible because there are countries in which you have a couple that has 3, 4, 5 child. In this very moment, one of the things that is clear is that especially in the, how can I say, the Europe, for example, United States and so on, many of the young people are even thinking about not having child. This is true, but this will be compensated in the other side by African and Asian people, which are just still growing, and they still have this mentality of the having more child will ensure their livelihood. So it's important that at the end, we wouldn't study in a steady state of 8 billion or 8.5 billion. It's true that the demographic models are going like that. But, and this for me is important, the economical model and social model has to be completely reinvented, because we cannot grow. We cannot grow indefinitely. And this is very simple to understand. If you have a plate in which you have bacteria and you have food, okay, agar, for example, and you put a small quantity of bacteria, the bacteria will grow until the food is depleted. Once the food is depleted, the bacteria die. We are the bacteria in some way, and the overall Earth is the food, if you want. It's extremely simplified, but at the end, we have a limited planet in which we will have, during the next 20, 30 years, 11 billion people. I'm sure about that. But as Marc, you said, we have to just reorder things just to have the opportunity to really survive.
Well, sometimes the only way out is through, and I think we are in this condition. The conditions are rough. We need to be very worried, but many economists will tell you that creativity in a society is always brought by the young, and you need to have children in a society. You need to have new approaches and to sort of new energies. That's what I think, that no society is going to give up, or we've seen, I mean, societies that give up on this sort of approach of having more children, etc., sort of lose the battle, and they become more slow, and they stop like being able to provide a good way of life, which actually a good way of life is another of the concepts that need to be reviewed. Because probably, Adriana, you want to reduce population to maintain a certain lifestyle, which I think may also be reviewed. And that's why I was talking about meditation and going deep inside, so that each and every one of us understands what's really needed and what's really important.
So, continuing. We have also a question from Giuseppe Guarnieri to Sergio regarding active evolution. He says that, I think that the speed at which environmental conditions are changing can represent a problem for the organisms that form animal forests. He continued and said, we know we have a peculiar life history traits. We also know that the successful of a restoration intervention is highly species specific. That we have enough time to adapt to the evolution of a species to the rate of changing, which is characterizing the Anthropocene.
The cold and the immediate response is probably not, but I can do that. I can do that. I have to try. I'm not a techno-optimistic person. I'm not. I mean, sorry, but technology is not saving. It wouldn't save us. The only thing that will save us is change the paradigm, completely change the paradigm. Okay, but this is not only my hands. I mean, what I can do is just try to figure out how to solve the problem with other professionals like Adriana, like Marc, like many other people that is working. Giuseppe is right in the sense that there are 2 points here. First, that we have not very much information about who is the best species, how to treat the best species, how to do with transplantation, so on. This is clear. And this assisted evolution that we have been seeing in Australia, for example, is seen as a desperate way to just try to fix it. But on the other side, you see the Australians presenting their work, and they have been there in looking at their works in the Congress and so on, and they are trying to implement this kind of imagination, as said Marc, to improve their situation, because they know that they are in a big mess. So it's true, this species specific. So there will be species that will work, others that will work, and we don't have enough information for some species to make it optimize it yet, because we don't have the thousands of years of gardening that we have for land. On land, we have thousands of years, for example, or of cultivating crops, or, for example, of silviculture. It's not the last 50 years that we have been optimizing. On the sea, the optimization methods are from the last 30, 40 years. However, I would say that making in the proper way, we could have enough tools, ecological tools, to apply them correctly and do a true marine gardening. Of course, it will work perfectly. I'm not sure about that, of course, but I have to try. We have to try, and we do have how can I say? We have the protocols to try to optimize this kind of approach.
And just continue on this topic. How big do you think our sea forests from with algae or corals have to be to counterbalance this this ratio of
if you sell, I put some numbers about the continental shelf making this kind of transplantation in deep areas. In deep areas, not at very deep areas, 80 to 150 meters depth, which are difficult to reach, okay? You have to sum all the efforts that will be done in restoration in coastal areas, in shallow areas, like Marc said, for example, and also other kind of programs. In this case, it's not only to counter, it's to say, okay, we have this kind of millions of tons that are going out from so to contrast them, we just put up, no. First, stop with the carbon. It's the first thing. It's just try to figure out how we can manage this point, which is just eating us. I mean, in the last 20, 30 years, we will have much heavier impacts in our society. But once you fix this problem, which is one problem, then you add this kind of restoration programs, not to go to the previous structures. It would be impossible to go to the pristine marine animal forest, marine vegetated forest, and even Amazonian or Congo forest. It is impossible, guys. This is not the point. The point is make possible to just have the opportunity to restore biodiversity, restore biomass in a way that nature will go through during the next centuries or millennia. But we have to do it. So again, the extension, I just put an extension. If you see the numbers, these very conservative numbers, with our 100,000, for example, 0.5 tons of carbon per hectare per year is translated to more or less 100,000 tons, taking into account this very small or small quantity of the continental plateau. It's not so small, but it's small, okay? This thousands, hundreds, thousands of hectares. Okay, but in any case, this is a program that may help us to recover or ally. So the structure, the three-dimensional life structures that are helping us to live in this planet.
Enough of the other speakers have any comments about this?
Not on my side.
So I'll continue. Matteo Pucciano have a question for all of you. He asks, what do you think is the most impending agent for a real change? Personally, I see a great cultural problem, especially in a world where negationism is coming back. This is for all of you. Negationism.
Negation is coming back. It is.
Yeah.
It is. It's coming back, of course.
Sometimes you need to rock bottom before you start to go up again, I guess. To me, the most impeding agent has to do with the difficulty to design transitions. I mean, we have operating systems in place that give life an organized social life and economic life for everyone. And even though we know they're not performing the way they should, providing an equilibrium with the resources and an equilibrium with our lives, transforming this and paying them, because most of these systems are not yet paid. So we need to understand and to design a transitional sort of period. And I think that the world is doing an effort on that right now. I'm actually optimistic and positive. The Green New Deal in Europe is, I think, an example. And from the point of view of the individuals and how to adapt to these changes that are coming, yes or yes, it's about consciousness. It's about developing awareness and consciousness. And I think that there's been a bloom also of techniques and elements in all cultures worldwide that make those paths possible and reachable by anyone who really wants to do that. So I think it's a battle that it's not a battle, but a process that is happening in different levels. And maybe, to me, the most important thing should be to speed it up. And speeding this up is about creating a conversation, and that can only happen if we start breaking certain boundaries. And I've always talked about developing in each and every one of us, as professionals and as people, the capacity to listen to the other guy, to the other arguments, so that we can, instead of competing even with our arguments and measuring our egos, but maybe we should start integrating, become a factor of integration in the conversation, so that we identify as a group what are the real problems and how to fix them. I think that's the essence of the transition. That is the real tool for this transition and transformation.
I agree.
I have to say, I have a T-shirt in which makes, and I love this T-shirt. Just it puts science doesn't care what you believe. It's the same. I don't care. I mean, I don't care what you believe about COVID-19. It's a virus. It's spreading. But politicians are extremely pressured. They have a pressure now because they have a system that is not working. They have an economy that is not working. And this is at the end. It's not because you are a communist, you are an anarchist. It's not like, I mean, just be mature about that, please. Then there are two possibilities. The first possibility is that in which the people is trying to be nostalgic about what happened, for example, in 1980s. They were happy and they have vision of the future and so on. And they want to go back, and this is not possible. And you try to make them understand that this is not possible. It's impossible now to go back. Then, first, is just make the problem real, make the problem as a real target to be solved by the politics, and then take action. And this is the second part of the people, which is much more young people, not all young people, but young people, that is looking in some ways, looking at us, like, what you are doing. I mean, just help us and stop just blaming each other and try to fix the modeling in ways in which you cannot. So these people has more and more a completely different awareness of what is really happening. They are not stupid. On the contrary, they are extremely intelligent, as all the generations that are more and more prepared and more intelligent, even if we don't realize. And what they see is that the change is now, and we have to do that. So the transition that was talking Marc is the important point, is how we face this transition and how we try to really do it. In other words, if we do nothing, and we still have this carbon emissions, this depletion of biodiversity, just in few decades, the world will be extremely gray and will be extremely difficult to live in many places of the world, and will be really hard, and there will be conflicts for the water, conflicts for the soil, conflicts for the seas, conflicts for the minerals, conflicts for everything, which are already being in action, but will be enhanced and multiplied by orders of magnitude.
On those terms, what I agree with Sergio is that maybe it's about choosing between competition and cooperation, or adapting, adjusting the level of competition, which is healthy also, with cooperation, just as nature does usually. And I think it's a biomimetic approach, I guess.
Marina?
I want...
Marina, no, sorry, Adriana.
I think that what we are doing now, today, is already important for...
It is.
This should be more applied in the future, this kind of meeting in which we can discuss and we can give our contribution in the possibility to change. This is important.
Yeah, to me, one of the things that I really liked about Adriana's work was she was comparing monoculture with polyculture, no? And probably one of the mistakes that our system is producing, one of the derivatives of the system, is the simplification of alternatives, a certain decrease of diversity as a concept.
Like we made the terrestrial habitat the same.
The same, but culturally, in terms of ideas, in terms of nature, I mean, you can see a decrease of diversity and a decrease of the capacity to accept diversity. And maybe changing that is the path, or that's at least what's directing the actions here at Underwater Gardens, is that let's help produce diversity, biodiversity, diversity of ideas, and let's ask more questions than give answers, which I think will open up, spaces and places of possibility that we can't even think right now. So that's why I believe that it's not a question of determinism in terms of population or techniques or a certain way of life that we understand now should be desirable, in a where awareness and maturity allows for humans to understand they don't need so much, and to identify better what's really important and what's really what they need. So if we somehow make our communities go in this direction, well, and sometimes, when you observe nature, there's certain facts that just happen no matter why. There's a wave of truth, if you want, that is guiding as a back music.
Yeah. I remember when I was young, I was at the university. There was an examination called Human Ecology. In 1970, there was at that time there was a topic, a fashion topic that was green revolution. Now is blue revolution. At the time was green revolution, and it was referred to the presence of monoculture in terrestrial habitat. to increase the production for human consumption. It was completely erroneous in mind, because it was ego
centric.
yeah. And now we changed our mind, and we talk about the more natural production. But at that time, it was a positive, a positive topic, a positive factor, the possibility to produce with this monoculture a lot of food for human consumption. This was
To me, one of the most wonderful things about nature and is understanding nature's generosity, as it allowed us to make a lot of mistakes.
Yeah.
It has allowed us a lot of mistakes, and now maybe this final test that we don't have so much room for more mistakes make us push. Is going to push us into finding the right solution.
We made lots of mistakes. In fact, to this with this scheme, this economical structure, we just make tries to enhance, and many things were very good. I mean, we have to be honest about that. We have a better education spread. We have more food and more people that is elder. I mean, it's not that it's everything negative. This is completely not truth, but there has a price. And the price was the acceleration of change and the acceleration of degradation, which now we have to say, hey, we have to do something, and we just are trying to manage. For me, I have to be honest, I always tell to my students that nature is a pale mother which doesn't care. I mean, for nature is always saying the same question. Are the oceans dying? And most of the people, when they start the course of marine biology, say, yes, it's dying, it's dying. No, it's not dying. It's not dying. Not at all. It's transforming, which is different. It's adapting to the new situation. The new situation is that we will have more microbes during the last million years. Okay. Then evolution will take this part, and if it disappear or not, they will just make another way, another how can I say, it will take another kind of curse of thing to adapt to the new situation, to the new energetic and material situation. But nature at the end is generous in the sense that, well, you can do just make experiments. But on this side is, well, you failed. It's your problem.
Okay.
I have a last question.
Okay.
For all of you. Don't you think that we are trusting too much on awareness, and that maybe we should become more political in terms of indeed working with the political system in order to work with, or maybe work ourselves in not only informing but also taking the decisions that we don't do it now. Yeah.
I understand your point. Adriana, what do you think?
I am very negative because I think that economy and ecology answer to the same, depend from a similar law, but they travel at a different time, a different speed. And economy is faster than ecology, and this is very difficult to convince, to make convincing the politician about something that they have to change.
I would say that you are right. I mean, if at some point we have to to make this kind of awareness of the problems and try to make this kind of communication, which is essential. We have been doing it. There are many people, many people that has been doing it. I mean, it's not a new thing. But we do have, as scientists, we do have to, and this is, of course, it's personal. This is my opinion.
Yes,
We do
I
have
agree.
to have a strong commitment. Stop it. I mean, if there is an opportunity, like for example, the water gardens opportunity, in which you may have the possibility to gather people and make things different, you have to try to analyze and to try to do it in the sense that stop to be complaining and to be on your office and say, oh, come on, it's terrible, look, it rises the temperature a little bit, the tendency of the sea warming is terrible. No, it's just, okay, just try to act. And of course, Giuseppe Guarnieri, for example, is right. I mean, for many reasons, probably it wouldn't work optimally and very well. In some way we will fail, but we have to try. And to try, we have to just be more committed.
You remember during the COVID, the lockdown, the nature, there was a revival.
Yeah.
But the economy say us, tell us always, we have to grow, we have to grow, we have to grow. And
and that's completely absurd.
Okay.
Marc, do you have any statement about this?
Well, remember this physics professor that had this jar full of round, ¿cómo se canicas, no?
Pebbles or small glass spheres or something like that.
And he was asking
Marbles.
students, okay, is this full? And everyone was, yes. Then he started to put like a smaller seed and yes, and then water. So I think that's the answer. I mean, there's room there's a lot of room in the universe and in our planet for growing. We just need to be more subtle, more smarter, and more sensitive in our approaches so that everything can fit and we can find the right proportion of everything. So we just need to keep on going.
Yes. So I think that we had an excellent discussion after 3 excellent presentations. Now we have to end our session, a great session. At the afternoon at 3 p.m. here in Brazil, in Italy, 8 p.m. we have our last session. So thank you all participants for be here with us. So spread the word, like I said before, share.
Yeah.
Okay, so thank you and bye-bye to you all.
Thank you very much.
Thank you.
Bye. Bye.
Ciao.
Ciao a tutti. Ciao a tutti. Come si...